Hello students and viewers, welcome back again to Science Capsule, a perfect self-learning tool for school children. In today's video, we will be discussing about one of the most important chapter under class 10th physics, that is magnetic effect of electric current. In the previous chapter, we have learned that when electric current is flowing in an electric circuit, then heat is dissipated. We call it as heating effect of electric current. Similarly, when electric current is flowing in an electric circuit, apart from heating effect, one more effect is also produced, that we call it as magnetic effect. So this video is all about knowing about the terms associated with the magnetic field generated when an electric current is flowing in a circuit. We will also learn about the direction of magnetic field produced and many more things which are very important as far as examination is concerned. So watch till the end of this video. If not subscribe this channel, subscribe this channel and press bell icon so that you won't miss any of my future uploads. So let us start today's session. When electric charges flow in an electric circuit, heat is produced. Along with this, magnetic field is also produced. About that only we will be seeing throughout this chapter. When magnetic compass, you are much familiar with magnetic compass. I will show you the magnetic compass. So here is the magnetic compass. The main purpose of this magnetic compass is to find the direction, right? By using this we can find the direction, which direction is north, south, east and west. When this magnetic compass is brought near the current carrying conductor, then you will find that the needle of the magnetic compass deflects. Under normal condition, the needle of this magnetic compass aligns itself in the direction of north-south. We know that Earth is considered to be a large magnet which contains north and south pole. And here in this compass we see two directions, right? One is north direction and another one is south direction. The needle which points towards the north pole of the earth is called the north seeking pole, or simply we call it as north pole. Similarly, the other end which is pointed towards the south pole of the earth is called south seeking pole or south pole. Under normal condition, we won't see the deflection of the needle. When the same compass is brought near the current carrying conductor, then we could see some sort of deflection of the needle, and this deflection is observed only if the magnetic field produced is greater than the magnetic field produced by the earth. So we can say that when the magnetic compass is brought near the current carrying conductor, the current carrying conductor also produces magnetic field, and which is greater than the magnetic field exerted by the earth. And let us understand some of the properties of magnetic field so that you will understand this chapter in a better way. When we talk about magnet, you must have studied in the lower classes as well. So let us recall some of the properties which will help us to understand the remaining portion of this chapter. So when we talk about the magnet, there are some important characteristics that has to be understood. The first thing is, magnet has two poles. One is north pole and south pole. Just before we have discussed the needle of the compass which is directed towards the north pole of the earth is called the north seeking pole or north pole, and the needle which is directed towards the south pole of the earth we call it as south pole. So every magnet has two poles. So here is a bar magnet. Here you can see very well, one is north pole and another one is south pole. If you cut into two halves, then how many poles you will see? Four poles, two north poles and two south poles. No, children. If it is cut into two halves, then each piece will acquire once again north pole and south pole. So this way we cannot separate the poles. So we can understand that every piece of a magnet have two poles, that is north pole and south pole. The second important characteristic of magnet is like poles repel each other and unlike poles attract each other. Now we have two bar magnets. You can see very well, here it is the south pole and here it is north pole. Here I am having two bar magnets, here north pole and here also north pole. When I bring the north pole to one another, then you can see very well that they are getting repelled each other, right? So, and if I bring both the south poles together, then you can see very well that here attraction we could not see. We are not seeing any kind of, instead it repels, right? So you can see very well that they are repelling. So like poles repel each other, and if I bring the unlike poles means north pole south pole or south pole north pole in opposite combination. here is a south pole and here I am having north pole. If I bring north pole towards south pole, you can see that they are attracting. So this is one of the most important characteristic of magnet, that is like poles repel each other and unlike poles attract each other. When I suspend this bar magnet freely in air, then what will happen? Earth is considered to be a large magnet which has north pole and south pole. When I suspend this bar magnet freely in air, after some time they align itself in the direction of north and south. So this is also one of the important characteristic. So based on this, we try to understand, we go into this chapter now. We know that magnet exerts a force of attraction with which magnetic substances like iron gets attracted towards itself. Now you see on the screen here a bar magnet and some iron filings are spreaded. Upon tapping on the surface, you can see very well that a pattern is formed to a certain region. From this we can understand that the bar magnet exerts some force with which the iron filings are attracted and a pattern is visible, right? Now from this we try to understand what is magnetic field and magnetic field lines. Now you can see on the screen that the pattern is visible to certain region. So from this we can understand that the influence of the magnetic force is to a certain region. Beyond that, its influence is not seen. So we can understand field, magnetic field, as the influence of magnetic force to a certain region around the magnet is called magnetic field, and the pattern what you are seeing is called magnetic field lines. And here line indicates that direction of magnetic field. The magnetic field lines what you are seeing on the screen has direction. So to know the direction of the magnetic field lines, we have an activity. From that activity you will be very much clear about the direction. Now we have a bar magnet. As you can see, this is the north pole of this magnet and this is the south pole of this magnet. Now the magnet exerts force around itself, we call it as magnetic field, and the magnetic field has some direction, we call it as magnetic field line. The magnetic force is extended to certain region, we call it as magnetic field, and we find out the direction of magnetic field lines by using a magnetic compass. Now I have a magnetic compass, as you can see here. To trace the path of the direction of magnetic field line, we make a region over here. So from here we will make a region. Over this line, let us keep the magnetic compass to find the direction. Now you see, when I kept the magnetic compass at the edge, you can see the direction, right? So this is the direction, we mark the direction. So after removing this, we can make the direction like this, right? So when I placed here, then you can see that the direction of magnetic field line is this, and when I keep here, then the magnetic compass needle deflects towards this direction. So we can mark here as like this. So as I keep continuously, then we will get here in this compass. You see the red line indicates the north pole. So here the red part is the north seeking pole. So the direction of magnetic field line is from north direction to south direction, right? Now if I keep the magnetic compass and pass over the magnet, then you can see very well that you see here the direction of the magnetic field is from south to north. It is observed that the direction of magnetic field lines outside the magnet is found to be originated from north pole and ends up at the south pole, whereas inside the magnet the direction is just opposite, that is the direction is from south pole to north pole. And the magnetic field lines can be represented by the picture as you can see on the screen, and in this picture you can see that the lines are crowded at the poles, which indicates that the strength of the magnetic field is more at the poles, whereas as the lines go away, as the distance increases, then you can find the distance between two lines, any of the two lines are more, which indicates that as the distance from the magnet increases, then the strength of the magnetic field decreases. From this we can understand that the magnetic field is inversely proportional to distance, which means if the distance is increased, then magnetic field is decreased. If the distance is decreased, then the magnetic field will be more. From this we can understand that magnetic field produced by the magnet is inversely proportional to distance. So now we are clear that when electric charges flow in an electric circuit, then magnetic field is produced. Now the question is, what will be the direction of magnetic field? In a bar magnet it is very easy because north pole is available and south pole is there. From this north pole to south pole the direction of magnetic field will be. But in case of a current carrying conductor, what will be the direction? To understand this, let us see here a simple electric circuit. Here the wire is on the north-south direction. Here what I am going to do is a magnetic compass is placed parallel and above the surface. Now when the electric circuit is put on, then the electric charges start flow from the north to south direction. In that case you can see very well that the picture shows the magnetic compass needle deflects towards east. Now if I reverse the flow of electric current, if the flow of electric current is reversed, in that case you see the magnetic compass needle deflects towards west. From this we can understand that the direction of the flow of electric current decides the direction of magnetic field. So on reversing, the direction of magnetic field also gets reversed. So there is a relationship between the direction of electric current and the direction of magnetic field. Now let us take one of the example. If the current carrying conductor is the straight one, then in that case what will be the direction of magnetic field? To know the direction of magnetic field in a straight conductor, straight current carrying conductor, we have a rule called right hand thumb rule. So what is that thumb rule? So let us take an example. Here I am having a straight conductor. Let us assume that this is a straight conductor and I am having right hand, so right thumb is also available. Let us understand to now how the direction of magnetic field could be found out. Hold the straight current carrying conductor this way. Here thumb indicates the direction of electric current and the fingers wrapping around the conductor is the direction of magnetic field. Then how can we understand this? Here you see the conductor, this is the direction of electric current and the direction of magnetic field will be this direction, right? So the fingers which are wrapping around the conductor, this way it is wrapping around, right? So this is the direction of magnetic field. If I invert the conductor, then in that case what will happen? Here you see the direction of electric current is towards downward direction. In that case the fingers are wrapping this direction. So this is the direction of magnetic field. So by using right hand thumb rule we can easily find the direction of magnetic field in a straight current carrying conductor. Understood, children? If the current carrying conductor is straight, then it is very easy to find the direction of magnetic field. By using right hand thumb rule we can find. If the conductor is in a circle or circular loop is there, then in that case what will be the direction of magnetic field? Now look at the screen. Here is an example of a conductor which is in circular shape, right? Here also the same rule will be applied, but the difference is as we move from one end to another, the direction, the position of our hand also changes. Now you can see on both the sides we can see two different directions. So this way the direction of magnetic field in a circular loop could be found out. A coil of many turns of insulated copper wires wrapped in the shape of a cylinder is called solenoid. Now the pattern of magnetic field lines you can see on the picture, which is very much similar to what we have seen in the case of bar magnet, right? Now here one side acts as the north pole and another one is south pole, and the magnetic field produced by the solenoid is very large. So we can say that the strength of the magnetic field is more in case of solenoid. Due to strong magnetic field produced by the solenoid, it can be used to magnetize magnetic materials such as iron, soft iron. When the soft iron is put inside the solenoid, it acts as a magnet. The magnet so formed is called electromagnet, since the magnet it becomes magnet only when the electricity is passed. Based on this, it is used in various places. For example, in removing scrap irons, the cranes are fit with the electromagnet. When it needs to be detached, we have to stop the supply of electric current, so it is no more electromagnet. So this way scrap irons can be transported from one place to another by making use of electromagnet. So I believe you understood how the direction of magnetic field is identified by making use of certain rules in a current carrying conductor. So that's all we have for today's video. If you found this video useful, then hit the like button. If not, subscribe this channel and press bell icon so that you will receive notification whenever I upload a new video. See you all on another day with a new concept. Till then, take good care of yourself.